Hello and welcome, my dear students. This is Engineer Shanawaz. Today, I am going to teach about how to induce current inside the loop. My dear students, this topic has a very importance for the NEET exam, for the JEE exam, for the IIT JAM. Every entrance point of view, this topic has an importance in every entrance point of view. My dear students, today we'll learn about how to induce current inside the loop. So, my dear students, we have an important phenomena here, that is electromagnetic induction. So, my dear students, today, first of all, let me know you about what is an EMI. This stands for electromagnetic induction. So, my dear students, what is the principle of this particular phenomena? This electromagnetic induction, what's the principle of it? So, my dear students, let me know you about what it is principle. So, my dear students, whenever the magnetic field is associated with the conductor, when we are going to increase or decrease in that particular magnetic field, accordingly current will induce inside the conductor. My dear students, if I have a magnet here, like bar magnet, it has its own pole, south pole and north pole. If I put here and conductor below it and put an galvanometer connected to this loop. So, my dear students, when I am going to move this magnet forward or backward, accordingly it will create induced current inside this loop, because it will create likewise this way these magnetic field lines. The magnetic field lines have a direction from north pole to south pole outside the magnet. If I move this magnet or if I move this conductor, accordingly this magnetic field will be associated with this conductor loop. It will create induced current inside the loop. It will create induced current in this loop. So that particular induced current will be detected by this micro ammeter. This is called sometimes galvanometer. It has a range. It can check its feeble current almost up to the range 10 raised to power minus 6. So, my dear students, what I have already taught you, this principle of EMI stands. What is the statement of this principle? It states that whenever the magnetic field is associated with this loop, it increases or decreases accordingly. The current will be induced inside this loop. This is the principle of this EMI. So, I may write down it first of all. Principle of EMI. Principle of EMI. It states that whenever the magnetic field is associated with the conducting loop, associated with the conducting loop, increases or decreases, increases or decreases accordingly the induced current will be generated inside the loop. This is the principle of EMI. So, in Hindi language or bilingual, I can say bina battery ke I am Michael Faraday. Okay, so let me move forward. So, we can generate, we have three ways to generate induced current, we have three ways to generate induced current inside the conducting loop. Inside the conducting loop, the first way is, we have three different ways to induce current inside the loop. The first way is by motion. If I consider here a part of a loop is nothing but a closed path. If I put a magnet here having south pole and north pole, if I give motion one among the two, it will accordingly the current will be generated inside the loop. If I move forward this magnet to this loop, it will create magnetic field line like these ways. Accordingly, and induced current will be generated inside the loop, and north pole will be generated here, and the current will be anti-clockwise direction. And the direction of magnetic field will be accordingly vice versa, that is, it will be clockwise direction. So my dear students, we have three different ways to induce current inside the loop. The first way I have discussed here, by motion. Either we will give the motion to the magnet or this conducting loop, and accordingly the current will be generated inside the loop. And the second way is by changing the area of the loop. So my dear students, by changing the area, accordingly the current will be induced inside the loop. If I consider here, for example, if I consider two loops here, one having the diameter of like radius 2 centimeters. For example, if I have conducting loop next to here having 10 centimeter radius, if I put here a magnet, it will create, for example, 5 magnetic field lines like this. Likewise, I put another magnet here having south pole and north pole. If this magnet forms here 10 magnetic field lines, accordingly the 10 magnetic field lines will be passed through this conducting loop. Okay. So my dear students, this have an area lesser than this. This will create here less induced current. Induced current will be less because this have an area less. So my dear student, this loop has an area of 10 centimeter. This is a radius of 10 centimeter. This having much a larger area than this one, because having more area will generate more induced current because area is more. So my dear students, I have discussed two ways how to induce current inside the loop. First way that was by giving a motion either to the loop or the magnet. Accordingly, the induced current will be generated inside the loop. The second thing is by changing the area of the loop. Either we'll put here two loops having 2 centimeter area and 3 centimeter area. For example, this area passes only 5 magnetic field lines because this has a lesser area, and this has much field lines getting passed through this because this is an area more. This is the second way how to generate induced current inside the loop. My dear students, the third way is by changing orientation of the loop. This is the third way how to generate induced current inside the loop. This is the third way. So my dear students, here I am going to discuss how to change an orientation of a loop and induced current will be generated accordingly. So my dear students, if I case first here, if I discuss case first here, so two fields will be discussed here. One is uniform magnetic field, one is uniform magnetic field, and one is non-uniform magnetic field. So these two terms will be accordingly. So what is a uniform magnetic field? If I consider here magnetic field like this, this is the direction of magnetic field lines, okay, and second magnetic field is here. So my dear students, what are you getting from these two things here? If I consider this one and this one, so my dear students, is a clear vision here that these magnetic field lines have an equal species having equal magnitude of field lines. This is sometimes denser and sometimes narrow. Narrow, denser, narrow, denser. There is a gap between, there is more gap, there is less gap, there is more gap, there is less gap. So I can define here the uniform magnetic field is that type of magnetic field which is neither wide, which is neither wide, which is neither wide nor dense, having equal spaces above to the equal magnetic field lines. This is uniform magnetic field. This is sometimes at most places, sometimes wider, sometimes denser. This is considered be to the non-uniform magnetic field. Non-uniform magnetic field. Okay. So let me discuss the third case by changing the orientation of the loop. So by changing the orientation of the loop, I have discussed the two terms here. By changing the orientation, by changing the orientation of loop. So my dear students, if I consider here magnetic field, uniform magnetic field like this way, uniform magnetic field lines, this is a magnetic direction of magnetic field lines. If I place a conductor here likewise this way, first case number one, case number second, if this is a magnetic field, if I put conductor likewise this way, case third, this is the magnetic field, if I place conductor here likewise this way. So in the first case, all the magnetic lines, field lines getting passed through this conducting loop. This is the conducting loop here. This is the conducting loop. This is the conducting loop. This is the direction of magnetic field lines. This is the conducting loop CL. This is the magnetic field. Okay. This is the conducting loop. This is the magnetic field. So my dear students, if I discuss the first case of this, by changing the orientation of the loop, is clear here that all the magnetic field lines are passed through this conducting loop. So if I consider here the magnetic field lines in the conducting loop is making an angle of 90 degree. Okay, here only if I tilt it, if I oriented it, if I tilt this to the some external angle, if I give a slope to this conducting loop, it will create likewise 45 degree angle. And here is clear that magnetic field lines and the conducting loop have 0-degree angle. This is a 0-degree angle. So here in the first case, all the magnetic field lines getting passed through this conducting loop. So I can generate here maximum induced current. Maximum induced current will be generated here. So you have to remember here. Case number first. In case number first, all the magnetic field lines are getting passed. That means the conducting loop and the magnetic field is having an angle of 90-degree. So I can generate here maximum induced current, because it is clear in this pictorial representation here, all the magnetic field lines are getting passed through this conducting loop. So if I discuss second case of this, by changing the orientation of the loop, if I give the slope of the to this conducting loop, it will just tilt to this some angle. If I consider here 45-degree angle, all the magnetic field lines are not getting passed through this. So only 4 lines are passed through this conducting loop. So my dear students, here in case number second, is a clear here, all the magnetic field lines are not getting passed. So I can generate here minimum magnetic field at 45-degree. Induced current will be less. So I can generate here minimum induced current, because all the magnetic field lines are not getting passed through this conducting loop here. So I can generate here maximum induced current will be generated at an angle of 90-degree, because all the magnetic field lines are getting passed through this conducting loop. So is the case number second, and in case number third, I can clearly say that nothing is getting passed through this conducting loop. So I can say here zero induced current will be generated in case number third. At there is the angle between conducting loop and this magnetic field is totally 0-degree. They are parallel to each other. Okay, here you can see here. So in case number third, at an angle of 0-degree, I can generate zero induced current will be generated. This was all about how to induce current inside the loop. So I hope you have, if you have any query related to this, comment down that particular comment, and have good day and thank you.